That's important. So it is fourth root in both cases, which is great, but what's underneath the radical? Is it the same thing underneath the radical? No, it's not the same thing. So let's simplify it and see if we can actually get somewhere to combine. So what does fourth root mean in exponential form? 2 to the 1/4. Well said, yes. So it's 2 times m to the 9th, p to the 6th to the what? 1/4 minus 3m squared p times mp squared to the what? 1/4. So if we want to actually combine, or in this case subtract two things, we're going to try to build the same thing. Like this and this needs to be the same in some way, right? In some way. So what do you do with, let's try this. What do we do with powers of powers? You multiply them, exactly. You do multiply them. So you take this 1/4, you multiply times 9, so you get 2m to the what? 9/4 and p to the what? 6/4 minus 3m squared p m to the what? 1/4 and p to the, so it's okay if I do 1/2? So if that's 1/2, what can I change this into right here? 3/2. Okay, so now we're just in purely exponential form. You might have done a different path, but this is what I would do. So now you look at this and say, hey, is there anything we can combine over on the right, on the term on the right, is there anything we can combine over here? There's p's and the what? M's, right? So let's leave this one alone. 2m 9 to the 4th, p to the 3/2 minus 3, well, it's m squared and m to the 1/4. So how many fourths is that?
2. 2/4.
Nope. You add these. 2,
Yeah.
nope.
9.
9/4, correct. What is 2 plus 1/4, everybody?
You multiply 2 times
You do
4
not multiply.
and then add the 1 to get.
So you're going to get 8
9
over 4 plus 1/4 is what? 9 over. Yes, nice. So it's 9/4. Hey, is that a good thing? Mm-hmm. And then you have p to the first, right? That's what the invisible power is. What's 1/2? Oh, 1/2. So that's going to be p to the what power? 3 over halves. Exactly. Hey, do we now have the exact same thing? M to the 9/4 and p to the 3/2. You have 2 of them and you're subtracting 3 of them. So what is this going to equal? Negative 1 of m to the 9/4 p to the. This one worked out pretty well. This one worked out pretty well.
Cancel them out.
No, you have 2 apples and you're taking away 3 apples. So how many apples do you have?
Oh, okay, got it.
Negative 1 of them. It is really tempting to be like, I want it to go away. No, we're not dividing here. We're subtracting. We're subtracting. Just take it carefully. Go carefully. There's other paths. The book tends to go on a path that I think is longer. I think this is pretty straightforward. I like going to exponential form personally.
Is it? Oh, okay, yes.
But you don't have to.
No, you don't have to. I mean, then yes, you could write this as negative the 4th root of m to the 9th times the square root of p cubed. You could write it like that if you wanted to. It's the same thing. Okay, let's do another one. Who has a second one that they would like to see done? Okay, so let's look at the first one here. Square rooting, that's the square root of 125, the square root of a to the 5th, and the square root of b to the 5th. What power is square rooting?
2.
No. 1/2. It is 1/2. So this right here, is 125 a perfect square? No. So we want to look for a perfect square factor. Is there a nice perfect square factor? Yeah, so this is the same thing as the square root of 25 times the square root of 5, right? And this is a to the 5th to the 1/2 and b to the 5th to the 1/2. What's the square root of 25? So we have 5 square roots of 5. And this is where you have a choice depending on what you're going to do over on the other side. But this could be a to the, what, 5/2 and b to the 5/2. There's lots of different ways to write the same thing, but I'll leave it right there. What's the most important part of the simplification we just did? This part right here. You see this? What did this turn into? 5√5. That's what the important thing is. The other piece, there's different ways to structure it. On the other side, are we dealing with the square root? No, we're not. So we have the cube root of 125, the cube root of a to the 4th, and the cube root of b to the 4th. What is, you just need to know this. What is the cube root of 125?
5.
No. What times itself 3 times is 1? It is 5. You just have to know that. You have to know it. So this is 5 and it's a to the what power? 3/4 and b to the 3/4. So
Why is it
It is 4 over 3, thank you. It is 4 over 3. Thank you very much. So this is where I would have you almost stop, because at this point, here's what you'd have. You'd have 5 root 5, a to the 5 over 2, b to the 5 over 2, plus what? 5, a to the 4/3, b to the... This is where I would like you to stop. The book might do a little bit more, but here's the thing. Do you have any like terms right there? No. Not really, you don't. There are ways in which you can do things that might make you rewrite it, but here's the thing. You see the two green things, the things I underlined in green? Do they have the same powers? No. No. The book might rearrange things a little bit or write it a little differently, but I would want you to stop right there. There's no conclusively nice path to take. I like stopping here. That's what I like to do. Multiply everything in the first times everything in the second. So what's a times a? A squared. And then you have minus a root b. That's this one right here. Then you have plus a root b right there. And then what do you have? Minus b. Minus b. What cancels in the middle? The a root b. Those, sorry. These cancel, right? Yeah. So what are you left with? A squared minus b. And which one is that? A squared minus b? That is e. Okay? So the second one, I'll change up colors here. Second one is root a plus b, root a minus b. What's root a times root a? A, and then you have this, so you have minus b root a. And then you have what? Plus b root a. I tried to write a radical sign and an a at the same time. Minus what? B squared. What cancels? Yeah, so you have a minus b squared, which is a minus b squared, that's c. We'll do one more. Square mean. What does squaring mean?
You do it twice.
Multiply it by itself, yep, do it twice. So this is going to be the square root of a minus the square root of b times the square root of a minus the square root of b. So that's going to be a minus root a root b, right? Minus root a minus root, not minus, times, right?
Isn't that the same as root ab?
It is. And then it's plus what? B. Plus b. So what do you end up with here? A minus 2 root ab plus b. So which one is that? I think it's D. The equation rules stay the same. If I add 5 to one side, what do I add to the other? 5. What you do to one side, you do to the other. There's a few things we're going to add in. There's a few things that are new. One of them is it is possible to create solutions that are incorrect. What I mean by that is you could do all the right math. You're going to get maybe 2 answers. And then what do you have to do with those 2 answers? You really, really need to check them because there's always a chance now that one or both of them isn't actually an answer. You can create false answers. So, for example, not creating false answers, but let's talk about each of these cases right here, just from right in front of you. Let's take a look at this one, girls. You have the square root of x minus 4 is equal to 8. Could you do that one in your head? Could you tell me what x is in your head? Raise your hand if you can tell me what x is by doing that in your head. The square root of x minus 4 is equal to 8. Can someone tell me what the answer is? David.
Is it 68?
68, exactly. 68 minus 4 is? 64. Square root of 64 is? 8. Yes, some of these you can do in your head, but that is not going to be the case most of the time. So what do you think you would do mathematically to solve this equation? What do you think you should do to both sides first?
Separate.
You can't separate what? You can. It's not multiply. What?
Isolate x.
Well, we want to isolate x. That's our goal. But what mathematical operation should we do? Noah. Verdi. Square both sides. What's the square root of a table times the square root of a table?
A table.
So what's the square root of x minus 4 times this? Oh, so it's x minus 4 is equal to?
8.
No.
No, 64.
So x minus 4 is equal to 64. So what? X is equal to 68. Are there going to be methods like this for each equation that we see? Absolutely. They might get a little bit more difficult, but they're all similar. The rules stay the same. So first of all, check answers. This is effectively what all of this boils down to, you can get, they use this word here, where is it? Extraneous solutions. Solutions that you get using these methods might generate extra solutions that don't work. So they're not really solutions. That's why we call them extraneous solutions. So if I asked you to do this one, what should you do first? So we end up with 3x plus 4 is equal to 64. Then subtract what? So 3x is equal to?
60.
So x is equal to?
20.
Which is 20. Exactly. Nice. So some of them are really straightforward. You will definitely get ones that are very, very straightforward. Now, what are the steps? You need to make sure you isolate the radical. On this one, is the radical isolated? It is. Is there anything tacked on to the outside of that? No. So the first thing you always check is that, is it isolated? Yes. And then you apply the power rule, which is what we did here. To get rid of a square, what do you do to both sides? If it's a cube root, what do you do to both sides? Cube both sides. If it's the fourth root, you multiply it to the fourth power. Well, it's not quadruple. You raise it to the fourth power. And then you solve. But what's the last step that's super important? Check your answer. It's really important. So let's take a look at this one. What's different? What's slightly different about this one? Equaling 0 is okay.
That's the plus 3.
So what do you do first? Subtract the plus 3. So you get the square root of 5x minus 1 is equal to?
-3.
Why did we do that? Because what was step 1? Isolate.
The radical.
We got to isolate. Exactly. So now what do we do to both sides?
Isolate.
You're just going to say isolate over and over? Yeah. So 5x minus 1 is equal to? -3 squared, which is? 9. So 5x minus 1 is equal to 9. What should I do to both sides?
Subtract 1. Oh.
So
I tried to be faster than that.
what does x equal?
2.
2. So let's check this. How do you check the kids? Shh. What do you do to check? You take the 2 and where do you plug it in? So label it check. So you have the square root of 5x minus 1 plus 3, but instead of x, what do you write?
2.
So 5 times 2 minus 1, so you have the square root of 9. Right?
Which is 3.
Plus 3. So that's 3 plus 3 is what?
0, no.
Is 6. So therefore, that one doesn't work. So are there any solutions?
No.
No solutions. So to do this question, your answer to this is there are no solutions. This should make logical sense because here's the thing. When you take the square root of something, can the square root of something ever be negative?
I hate when there's a possibility.
Can you take the square root of something and be negative? The square root of 16 is 4. The square root of 9 is 3, the principal root. And then you add something. If this is positive and you add something to it, can it ever be 0? No. So does it make sense that there are no solutions? Yeah. So this is all correct. This method is fine. But then what do you have to do?
Check.
Because guess what? That one answer might not be correct. Yes.
If we see something where
You have to check for. What's the first thing you always need to check for?
Make sure that
Is the radical isolated?
Yes.
Is the radical isolated?
Yes.
Yes. So now what do you do to both sides?
Square.
Say this out loud after I say it. Square both sides.
Square both sides.
What's the last word?
size.
You have to square both sides, not individual things.
Everything.
So you square both
So put
sides.
those in parentheses.
Exactly.
Got
So
it.
if I do this, if I square both sides, it's this squared and this squared. So it's going to be 4 minus x. When you square something, what does that mean?
You multiply it by itself.
So it's x plus 2 times.
X plus 2.
What mistake am I trying my best to have you not do?
Have break take
X
2x.
squared
Plus
uh,
2 squared. That's not true. It is not x squared plus 2 squared. I can guarantee you're going to do it. I'm sorry, but you're going to do it. Try your best not to do it. So what's this actually equal? What's x times x?
X.
No.
I was right.
Plus 2x. Plus 2x plus what?
4.
4. You have all of these, right?
So it's going to be x squared.
So
plus
4 minus
4x plus 4.
x squared plus 4x plus 4. What kind of equation is this, kids? This will bite you hard if you really don't pay attention to this. What kind of equation is this now?
It's a factoring.
Yeah, this is a what kind of equation?
Perfect.
Cubed.
This is a quadratic.
Yeah.
So what do you have to do to solve a quadratic? What's step 1?
Put together your common factors.
Yes, and then what?
factor.
Before you factor it, you have to make it equal what?
0.
It has to equal 0. So what are we going to do with, let's subtract 4 and let's add x to both sides. So what do we get? 0 equals x squared
Plus 5x.
plus 5x.
That's it.
That's it. Now what do we do, Bertie? You said it before.
Factor.
We love factoring, but we had to make it equal 0 first.
Oh, you can take out x.
X times x what? Plus 5. So you know there's two things. X equals 0 or x plus 5 equals 0. So what does that mean? X equals 0 or what? X equals -5. So what's the last thing you need to do?
Check it. See which one's
So let's go back to the original equation, which was, our original equation was the square root of 4 minus x is equal to, question mark, x plus 2. Let's plug in 0 and see what happens. So when x equals 0, what do you get? The square root of 4, does that equal 0 plus 2?
Yes.
Does 2 equal 2?
Oh, yes.
Yes. So this one is, yay, we're okay. But what about the next one? Let's do it in green here. The square root of 4 minus x, does that equal x plus 2? What are we plugging in for x now?
-5.
What's the square root of 4 minus -5?
It'd be 4.
9.
Square root of 9, so that's what? 3. And you have -5 plus 2, what does that equal? No.
-3.
This is where if you are sloppy, it will be wrong. You have to be real careful. So is this a correct answer? No. So what's the only answer here?
0.
0 is the only answer. You have to check.
Can you have 2?
What I'm going to do is square both sides. If I square the left side, what does the left side become? Can someone tell me? Raise your hand. Who can? Hannah.
5x plus 6.
Sarah, stand up. Thank you. So what does squaring mean? What does squaring mean?
Something by itself.
Yeah, multiplying it by itself. Thank you, no, that's exactly what I wanted. So what do you have to do over on the right-hand side? What's 2 times 2? 4. And then you get minus 2 times the square root of 3x plus 4. And then what do you get again? Minus 2 times the square root of.
3x plus 4.
And then you have the negative square root of 3x plus 4 and negative square root of 3x plus 4. What do you end up with? Plus 3x plus 4. Are there a lot of terms you can combine here? Can you clean up anything here?
Yeah.
So on the left, you could keep it as 5x plus 6 equals 4 minus, you have -2 of them and -2 of them, so how many do you have?
4.
Minus 4 times 3x, oh, look at that, plus 3x plus 4.
So that'll go to 3x, or -3.
So what do you have? 5x plus 6 equals 3x. That's here, right? What's 4 plus 4?
8.
Plus 8 minus 4 times the square root of 3x plus 4. This might not seem better, but how many radicals are in it? 1. There's 1 radical in it. How many did we start with?
2.
So we're getting there. What was that first step I told you? What should you isolate? Let's isolate the radical. What should I subtract from both sides?
3x.
So let's subtract 3x and subtract what?
8.
8. So what do you end up with?
Negative.
-2x minus 2 is equal to
Negative.
4, 3x plus 4. What should I divide both sides by?
2.
Nope.
4.
Oh, I like dividing by 2. You could divide by 2 if you wanted to. If you divided by 2, what do you get? -x minus 1 is equal to -2. Sure, you could do that. Is our radical isolated? No. What do I divide by? -2. So what do I end up with? -x over 2, -2 minus 1 over -2 equals. Can we clean up the left first? Do you see a lot of negatives? What's a negative over a negative? So what does this become? X over 2 plus equals the square. Oh, look. Now what can we do to both sides? Okay, so the first part of your homework is to finish this, and the second part is in Veracross. See you, kids.